Welcome to ML Foundations Module 7, Machine Learning Operations, Session 2, MLOps with H2O.ai. In this session, we're going to go over the MLOps software, walk through different examples, and end with pointers to a tutorial that you can take on your own. Here's an overview of what we're going to cover in this session. We're going to start with the MLOps software architecture. Then we're going to create a model. We're going to show how that model can be stored and shared with teammates. Then we're going to deploy the model, show different management and monitoring capabilities, and finally use that model from an AI application. At the end of the session, we'll show you where you can go and try this on your own with a take-home assignment. For those of you that are new to ML Foundations, you can check out some of the prior modules that have been presented, both the AI Foundations track and the ML Foundations track. Okay, let's start talking about the MLOps architecture. MLOps is about pipeline management, and here you can see different phases of the life cycle of a model. It starts with data sources, data prep, training the model, exporting that model into a managed system, deploying the model, getting new data to make predictions, monitoring that model, and then capturing the data so that you can then use it to retrain or recalibrate and basically close the feedback loop. So what MLOps does today is orchestrate the things in the gray area. So this gray big box on the right-hand side. It handles the management, the deployment, the monitoring, the capturing of the data, and in the future, we'll also handle the retraining as well. The artifact is very important. So the H2O software, whether it be driverless AI or H2O open source, they both produce a Mojo artifact, and that Mojo artifact is extremely flexible. It's got really, really nice properties for deployment. In particular, it can be used for low latency scoring, for high throughput scoring, and that artifact contains all of the good stuff that comes out of the model operation, the model creation process. Basically, you can think of that Mojo as the thing that you can extract from the training environment, which might be very, very bulky and heavy. It might be having very, very strict security policies, but you can take that Mojo artifact and extract it from the training environment and put it into a scoring environment with just a thin runtime. So that runtime contains all of the code necessary in order to inference that Mojo, and you can really run it anywhere. It's very portable. You can run the Mojo runtime on-prem or in the cloud. You can use that Mojo runtime in Java or in C++ or Python or R sitting on top of C++. It's very, very well suited for batch as well as real-time use cases. And this Mojo runtime is what we use in MLOps in order to run and orchestrate models. The algorithms themselves are, whether they're from driverless or from H2O3, the runtime supports a broad range of algorithms for classification and for regression in MLOps. And so basically, you can take the output of your training job and just deploy it very, very easily using this workflow. Here you can see the MLOps very, very high-level architecture. What MLOps is trying to do is to provide a centralized place for you to be able to store models and the data sets that created the models, to collaborate between multiple teammates to be able to use those different driverless AIs that are inside of your training environment and in a way that allows them to talk to each other through MLOps. So MLOps in the center has a storage component, as well as this concept of a project, a networked project. And that networked project is what allows the different driverless AIs and H2O3s and the users that are interacting with them, the data science users, to store their projects in MLOps and then deploy them easily. And this is what we're going to show you in the software in a few minutes. The deployments themselves are pods inside of Kubernetes environments. So MLOps knows how to create REST endpoints inside a Kubernetes environment from your model. Here's a deployment diagram, again showing you that same picture of driverless AI talking to MLOps, but now it's exposed in a little more detail, showing you more components. Here you can see again at that center is that model storage component with the MLOps accepting the model export from driverless AI, which we'll show you in just a minute. There's a UI, the model manager UI, that's sitting on top of the MLOps backend components. And then the deployments themselves, if you go into the UI, choose a model, and then deploy it, what you'll get is a REST endpoint inside of a Kubernetes pod. It's a container inside of a pod, and then the Mojo artifact is overlaid into that container. And now all of a sudden, MLOps is able to orchestrate and deploy lots of different models and manage them very easily. Here you can see this user on the left-hand side, sort of on the top, interacting with the different models using the REST API. And that user, you can think of that user as an application actually, or a person using an application. And what that person is doing is sending new data, asking for predictions from the model via this AI-enabled application. And MLOps is taking that request, sending it to the model, making a prediction, and returning the response to the application. In addition to that, the data itself, that new prediction that's being made, is getting stored for monitoring purposes and future retraining purposes in this influx database that's part of MLOps. And then you can view through a Grafana that's part of the system what's happening. The Grafana can also set alerts, and we'll talk about that in a little bit. So just to wrap up a few of the environmental details, basically containers are really core to this whole idea. The MLOps runtime for an individual model lives in a container. Basically, we are using Kubernetes to orchestrate those containers for individual models as part of a pod. The pod gets resources. Because it's running inside of Kubernetes, it's a very, very scalable solution. Kubernetes is also nice because it makes the deployment consistent from environment to environment. The clouds, all of the major clouds, Amazon, Microsoft Azure, and Google Cloud environments are all supported, as well as on-prem environments. And Kubernetes is what makes that pretty seamless, because the Kubernetes itself abstracts away a lot of the details of the individual cloud environments. So we can have essentially a consistent deployment regardless of whether you're doing it in cloud or on-prem. Okay, now let's talk about creating a model. MLOps supports two platforms today. Those are H2O's driverless AI and the open source H2O3 and sparkling water. In the future, we can support additional frameworks. The containerization approach allows replacing the runtime without changing the API, and that gives us a nice path for future frameworks. But today we support the two that you see above. The experiment we're going to use, the data set we're going to use, I'll just talk about it briefly so that when we run through examples, you'll have a sense of what's going on. This is a credit card data set from Kaggle. It's basically a default yes or no binary classification question. And let me just flip to the Kaggle page itself. Here you can see this is the default of credit card clients data set from Taiwan in 2005. Let me just scroll and show you the columns. So you can see for each row there's an ID, a limit, balance, the gender of the person, their education, marital status, the age of the person, and then the pay, bill amount, and pay amount fields all have history. So it's basically trying to show what happened last month, what happened the month before, what happened the month before that, and so forth. The pay column is the status. The bill amount is the size of the person's bill, and the pay amount is the amount that they actually paid. And then the value we want to predict on is default payment next month, which is a yes or no. Okay, let's go into driverless AI and train the model. Here, logging into driverless, we can see some data sets that I've pre-loaded in. This is the credit card data set, and I've done a test and train split prior to logging in here. Let's go take a look at the experiments that I've already built, and we'll take this credit card default 1 experiment and train another one off of that. So we'll do a new model with the same parameters. We'll name it credit card default 5. Keep these parameters, maybe bump up the accuracy a little bit, and kick it off to run. While we're at it, let's go into open source H2O.ai into the Flow web UI and train a similar credit card model here as well. I'm going to start by importing the data. Okay, now that we've got the data ingested, let's go ahead and split it into test and train. And let's go ahead and actually build a model. I'm going to choose generalized linear model. Here we'll pick valid as the validation frame. And again, we'll choose default payment next month as the response column. I'm going to ignore the ID column. Because we're doing a yes or no problem, let's change it to the binomial family. And we'll keep the rest of these as default and go ahead and build the model. Okay, that was pretty fast because GLM is fast. And now what we can do is, after taking a peek at these different metrics, let's go ahead and download the Mojo. And we'll just put that Mojo on our desktop for later. Now let's talk about the storage and collaboration capabilities of MLOps. If you remember from before, the center of MLOps is a storage component. Driverless AI and H2O can both export models into this storage component. And you can think of this as the hub where all of the experiment artifacts get stored and where people can choose from them through a UI that allows deployments using a very, very simple one-click kind of approach. So the storage component, as I said, is really the center of everything. And the project concept in the storage component is then networked out to the different driverless AIs, and people can export and import experiments from storage by contributing them to a project. These networked projects store both data sets and models. So you add a model, or in driverless, the linking word is what we use. So we link a model to a project that links the data set that model was trained on. We can then share that model with other teammates. And then that importing and exporting capability is sort of the core of the collaboration. And different people can work together to basically work on different parts of the workflow of a project. And you can see here this list of roles: the data scientist, the data science manager, ML engineers or ops people, AI application developers, and the business user. And let's talk a little bit more about what each of these folks might get from using MLOps. So the data scientists themselves, really what it does is provide an easy path to production so that your work can actually be used. For the managers of data science teams, it allows team productivity to grow. It helps with organizing models and experiments, helps to choose the best one, allows the folks on the team to collaborate by sharing experiments with each other. From an engineering perspective or an ops perspective, it allows these models to be deployed in a low latency, high throughput kind of way. So there's a very, very straightforward way to get a model into production as a REST API. It allows you to manage and deploy the models at scale. Productionizing the models is now easy and safe to do because there are guardrails around what's allowed for individuals. For app developers, people trying to write AI applications, what MLOps does is provide an easy-to-use infrastructure for automating things. Basically, it allows you to decouple from the application lifecycle itself the model life cycles. And by doing that decoupling, it allows people to update models without needing to change the app. And for the business person, all of these things put together means that they get apps that have AI embedded inside of them that allow them to make better data-driven decisions and improve business processes. Okay, now let's take a look at collaboration inside of driverless AI. Here we're back on the screen where we finished creating the model earlier. And let's go into the projects view. And here we'll create a new project. I have some that I've created before, but we're going to make a new one and put our new model in this project. And here what I did was I created a new project. I linked the model that we just made, this credit card default 5 model, into this project. That brought in the training data as well. And now those two pieces of information, the model and the training data, they're now in storage. So they've been copied, they've been exported from my local driverless AI into the centralized storage, which means that I can go into MLOps and see them. So let's go ahead and do that. This is the MLOps UI. I'm going to log in as the same user that we had in driverless AI. And here we can see the two projects that I had from before, and then the one I just made, this new credit card project. And if we click on this new project, you can see that the model is here, it's visible, and we can do stuff with it. But most importantly, what we've done is we've shared it. And now I can also share it with another person. So here we're logged in as data scientist number 1. I can go and share this with data scientist number 2, who's another user in my setup here. We can go ahead and share that with data scientist number 2, close this, and if I open a second browser, so here I've got a second browser, we'll log in as data scientist number 2. This is the driverless AI view. And if I go over to projects, you can see that same project is visible in driverless AI. And if I click on it, you can see that there are these little cloud icons here for both the data set and the model. And what that allows us to do, if we want to, is to import it. So if I click the import button here, then what will happen is we'll grab from storage that model and bring it locally. So it allows us, as two different users using two different driverless AI instances, to collaborate on a single experiment. If we go into the MLOps view for data scientist number 2, we also see that new credit card project. And here we see the same information that we had for the first user, and it's owned by the first user because that first user created the model. The project itself is owned by the first user. Notice there's no share button, only the owner is able to share the project. So the person that creates the project is the one that determines who else that project can be shared with today. Okay, now that we've been able to share a model and collaborate, let's talk about how to deploy one. There are 3 different kinds of deployments today. There is the single model, where you just take that model we just made and click a button and deploy it. There is the champion challenger approach, where you have a champion, a challenger for that champion. All of the predictions that go back to the application that requested the prediction come from the champion, but the challenger is there kind of on the side for comparison purposes. And then the final way is an A/B deployment, where you have some of the predictions being made from the A model, some of the predictions from the B model. And it's not just A/B, you can have as many models as you like. Other pieces of relevant information are endpoint security. So these models, when we deploy them, they go into a containerized REST endpoint service, and that's exposed as a URL, and that URL you can optionally add some security on it if you want to. Okay, let's show the actual deployment in the software. So here's the model we just made, and it's really very simple. Just click over here under the actions 3 dots, click deploy. Here we can choose the level of security. Notice that there are 3 choices. The first choice is no security at all. And what that means is when you make a new REST endpoint, you can send queries to it and they don't need any sort of passphrase protection. The second level of security is a passphrase that's stored in plain text. What that means is that if you forget it, MLOps will store it for you in the database, and you can recover that just by clicking on the eye icon, for example. Here the eye icon is showing us a default generated passphrase, but after we've deployed it, you can recover that from the UI. The third option is to store a hashed passphrase, and in this case, it's not recoverable from the UI. So if you forget it, then you'll need to recreate the endpoint and basically create a new password from scratch. Here, MLOps doesn't know the password. So you set it here, and then it's hashed, and the hashed value is stored in the database. But let's keep things simple, and we'll use no security for now. We'll just go ahead and deploy it, and you can see now in the deployments section here, basically this model spinning up through a few different phases until it's healthy. This doesn't take very long. It should only take a few seconds. There we go. Now it's healthy. And once that model is up, we can do things with it. So for example, we can click on a sample request. And here you can see what a curl command that you can cut and paste into your command line would look like to reach that model. If we go back into the other project that I deployed before, you'll see that we have a few more models here. And because we've got more than one model, we can look at the other endpoint deployment types. So there's the champion challenger and then the A/B testing as well. So the champion challenger we can create by just clicking an action and then declaring it to be a challenger. And basically, because we've got 3 different models deployed, we can choose the champion that we want this challenger to be comparing against. But for right now, let's just look at the one that we already deployed. Here we can go into the details of this model that we deployed earlier, and we can see, okay, the champion is CC default number 2, the challenger is number 3. Here they each have their own individual model IDs. It tells us stuff about when they were created, information about the scores that were calculated during training, and so forth. And then if we want to delete this endpoint, we just click this delete button right here. The other kind of deployment is the A/B deployment. And to make an A/B deployment, we can highlight a few models. Here I've chosen 3. You can pick as many as you want. And if we click on A/B test, here you can see this gives us the opportunity to specify the traffic ratio that is between the 3 models. Here for model number 1, we've chosen 10%, model number 2, we've chosen 10%, and model number 3, we've chosen 80%. The reason this is relevant is because these three models are all live. So basically, on a prediction by prediction basis, there's a coin flip that's made in order to decide randomly which of these different models will make that prediction. And the model that's actually chosen, the ID of that model is returned back to the application that made the prediction, so that you can know actually which of the models you're using for that particular prediction. So let's just recap quickly what we did to get a deployment. We started with driverless AI, making a model in driverless AI, exporting it into storage as part of a project. That project we could then navigate by using the MLOps web UI, and clicking a button to deploy it basically pushes that model into a new pod. It creates a new pod in Kubernetes and then links it to a REST API that is reachable from the outside by an AI application. Now let's show you deploying an H2O open source model. I have this project here from before. Let's go click into it here in the MLOps UI. And you'll notice that there's a model here, a GBM that I deployed earlier. It's already deployed and it's healthy. But let's deploy that GLM that we made a few minutes ago. And to do that, it's really pretty easy. We'll just click Add Model here. And all I need to do is drag and drop that into the window. And we'll name it GLM CC model. And now it's uploaded here into MLOps. And if I click deploy, and in just a few moments, it should be up and healthy. There we go. And if we go ahead and click show sample request, you can see this is all we would need to send that model a request and get a prediction back. So just a simple drag and drop, and H2O models are supported. Okay, let's talk about some of the management and monitoring capabilities now in MLOps. On the management side, we support model governance by allowing the storage component to contain the artifact. So the fact that that Mojo artifact lives in storage means that we have a copy of it and we can always refer back to it if need be. There's metadata attached to that model. We can show you that in the software in a few moments. And the model can be annotated with comments. So if as part of a sign-off process, you want to make notes about that model and have them attached, you can do that. You can also see events related to deployment. So when you deploy or undeploy a model, those events are stored with their timestamp in the MLOps database. On the data governance side, the data set used to train is associated with that model, and MLOps, the storage component, can store that as well. So if you want to go back to the actual training data, you can review it, reload it in, import it back, and look at it again and even train another model again if you want to. The influx itself, as we talked about, stores the prediction inputs and outputs. So when a new AI app makes a prediction request, that gets stored in MLOps so that we can use that information to train again in the future and close the feedback loop. And then the Grafana dashboard, which we'll show, is helpful for viewing real-time behavior. It shows us both what you can think of as computer science performance. You can see the latency of the endpoint and see from a timing perspective how those predictions are responding to their requests. And from a data science perspective, different information about the performance for things like histograms and even data drift. The Grafana itself, when different triggers are exercised from a data perspective, can also alert. So we can show you how alerts are visibly shown and how they propagate to the MLOps UI. From a drift detection standpoint, we use an algorithm called population stability index. We've got drift both built into the Grafana pane, as well as there's a separate real-time drift detection app, which I'm going to show you. Okay, let's take a look inside the MLOps UI now. Here you can see some of the projects that we had that we looked at before. Let's go into the new credit card project that we made. And here you can see from a management perspective, there are lots of different things visible here. We can start by seeing that the project itself has an ID. The models also have IDs. What this does is help us to make sure that we can track back when predictions are made where they were coming from. So the model has an ID, the deployment has an ID. What we can do is take a look at some of the different actions available for a model, and we can see that there are both the auto report that is available inside of driverless AI. You can download it from here as well. And we can also click on this more details to show you things like, for example, comments. So we can create comments for this model like we mentioned before. Here we can see some of the parameters of the model. We can see the metadata of the model. So here you can see some of the low-level driverless AI creation, model creation information, things like the experiment summary that appeared in driverless AI itself. You can also see it here. The individual model iteration information. You can see that in this view if you expand it. So it's just trying to give you details about the model without needing to dive back into driverless AI. A lot of them are available here. From an events standpoint, you can see when things are deployed or undeployed. Here it shows you a history of when this model was shared, when it was tagged, when it was created, when it was deployed, things like that. Back in the top view of this new credit card project, in addition to these IDs, you can see an alert status. We can go to another model in a moment, or another project in a moment, where some more activity is occurring. But just to give you a sense, it's showing you the state of the model, the original score that the model was trained against, and the original score that occurred during the training period. Just things like that. Dates, the owner, who created this model and the project, those sorts of things. If we go into a bigger project with more models, you can also see some interesting alerting information. So here, this credit card default 1 model has 22 fields that are green at the moment. These other 2 models have lots of fields that are orange, Green means the columns are receiving prediction data and that those prediction points are within the training bounds. There are no alerts on them. Orange means that there are no points. Basically, it's no data arriving to the models. And then red indicates some sort of issue. Let's go ahead and actually dive in to the Grafana dashboard for a given model. And here you can see right now there are no alerts happening. You can see that this scoring latency shows us sort of the computer science performance. It's basically the milliseconds that it takes for a prediction to be returned to the requester. You can see it's pretty consistently 1 millisecond. Occasionally there's a spike, but not very often. Here we can see the column types. Basically there's a panel showing us the different fields and their data types, including the response column. So default payment next month is the response column. Here these two panels show us the population stability index and the drift. Population stability index, again, tells us something about whether the data at the time of training is now matching the data that we see here in production. And these stability index scores are unscaled, but we can scale them and turn it into a drift score, and then it shows us points that have a value of a certain threshold should be treated as needing further investigation. Not points, but drift points representing a particular column. And then if we scroll down, you can see for each of the different inputs, as well as for the response column, there are scatter plots, heat maps, histograms. And if we go down, we can see all of the different fields associated with this model. One of them in particular is a little bit more interesting because I set up an alert for it kind of by hand. Here you can see the bill amount 1 value. And if I go and zoom in and go and take a look at the alert settings, basically what I've done is by default when these panels are created, it creates a minimum and a maximum threshold, and the lowest value in the training data is the minimum threshold, and the highest value in the training data is the maximum threshold. In this particular case, what I've done to show that the alerting is visible in the Grafana is to manually tweak this maximum for the bill amount 1 column and tweak it to be 300,000, and we can see that there are values here kind of above 300,000. And you can see that historically these red lines indicate that a value has appeared that exceeds that threshold, and then the green line in the timeline view shows you when that value has quote unquote cleared, or basically the alert is ending. So you can see sort of, right now we can see that an alert just triggered. We've entered an alert phase, and if I go back out of this view, we should see that now appear at the top. If we wait a few moments, we'll see that alert appear. And yep, now we can see bill amount 1 is alerting for a few seconds. If we scroll down near the bottom, we will see the response column. So this is kind of interesting because here we see a scatter plot showing us the predicted values over time. We can see a heat map, and here the color of the block represents the number of points. So the lighter color here, for example, this lighter color shows us that the count is higher, and the darker color shows that the count is lower, and then no block at all indicates that there were no points of that value in that time bucket. Here we can see a histogram and again, this window that we're looking at is the last 10 minutes, and this histogram is showing us the statistical breakdown of the predictions that we've made. And default payment next month dot one is the probability that we're predicting yes, that this is likely to be a defaulting payment. So we took a look at the different screens inside of MLOps. We took a look at the Grafana dashboard. Let's take a look now at the real-time drift detection application. Here you can see an updating screen showing you feature drift for each of the different features where the values are being updated in real time. Here's a drift value for each feature, and you can see the features that are needing more attention spelled out specifically in red. And here you can see the ROC curve drifting over time with an upper and a lower bound, and then the current value of the current calculated curve, as well as score histories for the AUC and for the drift. And finally, if we choose different features, going back, for example, to bill amount 1, you can see the training and the scoring values, and they're broken down into different histograms. Now let's talk about actually using a model from an AI application and show an example. So really all this means is how from the application we call the REST endpoint. And doing so is pretty straightforward. We'll show an example of doing that in just a second. Really what this does is allow us to decouple the model lifecycle from the application lifecycle. So it allows us to update the model, it allows us to change, an A/B model, things like that, without actually changing the application itself. Remember the REST endpoint, we deployed it from MLOps using just a one-click kind of an approach, and then when that REST endpoint is now running in Kubernetes in a container, we can call it just with a simple HTTP request. Optionally, that REST endpoint can be protected by a passphrase as we showed earlier, but for simplicity, we won't do that right now. So here I have a deployment that I started earlier. Let's go ahead and look at that sample request one more time. Here I'm going to copy that request into my clipboard and just paste it into a terminal window here. And you can see after I pushed return, the response came back, and this is the response from the prediction itself. And here we're getting two fields back, default payment next month.0 and default payment next month.1. And the field that we care about most is this .1 field, which is the probability that a yes was predicted. And here we can see that that's 0.31 for the sample request that we pasted in, which just has every field as a 0. And that 0.31, we can threshold any way we want. You'll notice here that there's no specific prediction returned. There's no class returned. It's just a number between 0 and 1. It's the probability. And you can take this probability and threshold it however you want. And the way that you threshold it, the value you use to threshold it will result in the confusion matrix that you'll get. What you'll also see here is the ID of the model that was used to make the prediction. And that's handy if you've got, for example, an A/B test situation, and you'll see that ID move between the different models in your A/B deployment based on the one that actually made the prediction for that row. So you have a good traceability there. Let's show this in one more kind of an environment. And this is a PyCharm with a Python program and basically a really, really similar setup. I'm going to go ahead and just run this right now. And you'll see that we got an HTTP status code back and a response payload from Python. You can see this Python program is about 80 lines or so, and it looks very similar. Really what it's doing is stuffing the different column names and values into a row and then posting that to the endpoint so that we get this payload back. And once we have this payload back, we can parse it as a JSON, and you have the prediction actually in your hand in a piece of code, and now you can do stuff with it to make your application an AI application. We'll close this session with a link to an assignment. You can go and try this stuff on your own by playing with the driverless AI tutorials on the training.h2o.ai website. You can also attend quiz and study group sessions on Saturday and Sundays at 10 a.m. And here are some links to external resources you might find helpful. Thank you for attending the session.